Hello everyone and welcome to lab number 1 of our series of light and optics experiments. My name is Mo Hasanovic. I am with Indian River State College and LASER-TEC, Advanced Technological Center of Excellence in Lasers and Fiber Optics Education. The center is supported by National Science Foundation. The title of this lab is Laser Safety. Laser safety represents the subject that needs to be introduced to any personnel that comes in touch and operates different types of lasers in a photonics lab. Laser represents a light source that has a very directional, coherent light, so that light has a pretty strong intensity and as such poses a hazard to human eye and in certain instances to human skin and other organs. So it's very important to address the issue of the safety in a photonics lab so that we avoid or prevent any kind of injuries to the personnel that is operating the lasers. There's different types of lasers. Some of them are emitting light in a visible spectrum. Some of them are emitting light in an invisible spectrum, either ultraviolet or infrared. Lasers are characterized by different types of characteristics such as intensity or energy, wavelength, diameter of the beam, etc. And in general are classified into different classes according to the level of a hazard that they pose. The level of the hazard that they are posing is determined by their intensity as well as the duration of the exposure. So since the lasers are posing a hazard and can create injuries in the lab, it's very important to address the safety concerns. And it's very important and critical that the safety rules in the photonics lab or any other environment in which lasers are operating are addressed and practiced at all times during the operation of the lasers. So in this lab we are going to introduce the laser as a light source. We are identifying important properties of a laser and differences between the characteristics of a laser and other light sources. We are stating safety rules that need to be implemented in an environment in which lasers are operating. And finally, as a hands-on part of this lab, we are going to demonstrate the propagation of the laser beam coming out of the laser as well as the way how a laser safety goggles are blocking the laser beam and thus protecting the eyes of the personnel working in a close proximity to these important light sources. We are going to use the following equipment in this lab. A laser diode module. I'm using here an affordable laser diode module that's part of your kit. You can use any other class 1 laser pointer. Here we have a laser safety eyewear that's also part of your kit. I'm using here a small bottle filled with water, the small pumped spray that's going to produce the mist. And finally here I have my landline phone. The reason why I'm using my landline phone is because of this small red LED. Part of this lab is going to be to compare intensity of an LED to the intensity of the laser pointer. So you can use any electronic device that has an LED. Okay, so here I position my laser pointer. I use the tape to tape it down to the paper, and I also elevated it at an angle so that it hits this white screen here approximately at the same elevation as the elevation of an LED on my landline phone, and I can compare the intensity of this laser beam that's hitting the screen to an LED. You can immediately see that a laser pointer is producing a much stronger, a much more intense reflection on a white screen as opposed to an LED. That's one of the most important properties of a laser. Lasers are producing a very directional light, and compared to LED, obviously the strength is much stronger. I also dimmed the light in the room now to increase the effect of my laser pointer. Now you can see a much stronger light that's coming out of the laser pointer as opposed to the light that's produced on this LED on my landline phone. You may probably be asking yourself if there's any way how we can prove that the red dot that we are seeing on the screen here is actually coming out of the laser. It's obviously intuitive that it's produced by the laser pointer, but the question if there's any way how to prove that. So what I have here for you is actually a small experiment that you can perform at home as well. So I have here a small bottle that I filled with water. I found it in my wife's cabinet. So it was empty, so it's basically a spray bottle. So I can remove this top part and fill it with water and then close it, and then I can actually spray to produce like a water mist. The reason why you are not seeing this laser beam coming through the air is because this laser beam is not reacting with the air molecules. You can see that it is there. So if I move my stick here, you can see that the laser beam is right there, but we cannot see it because it's not reacting with the molecules of air. So what I'm going to do here is I'm going to take my spray bottle and I'm going to spray a little bit of a water, and you'll see that if there is a water, if there is a mist in the air, the molecules of water are going to be react with the laser beam, and the laser beam is gonna be visible. So let's try to do this experiment. I'm gonna spray here a little bit in a controlled fashion. And finally, as a last part of this lab, I would want to introduce laser safety eyewear. Laser safety eyewear is present in every photonics lab. It's an important piece of protective equipment that's used to protect your eyes. Laser is a device that produces a very directional light, and that light is a hazard to your eyes. If it's pointed directly, even for a short period of time, a laser can create permanent injury to your eyes. So one way to protect your eyes is using laser safety eyewear. So laser safety eyewear represents personal protective equipment. And here we have a simple laser safety eyewear that's part of your kit. Every laser safety eyewear is used for a specific wavelengths and has a specific property, so-called optical density, that gives an information about an ability of laser safety eyewear to block or filter the light coming out of the laser. So here we are going to briefly demonstrate how this laser safety eyewear works. As you can see here, we have a laser source hitting our back screen, producing a pretty strong laser beam spot. And if you put this laser safety eyewear on a path of the beam, you'll see that it's going to significantly reduce the light. So here's the laser safety eyewear on the path of the beam. And then here, if we remove it, you can see how the laser beam spot on the back screen is significantly reduced, because the material out of which this laser safety eyewear is made acts as a filter that's blocking the light from passing through. And that's why over on the other side we are not seeing it. So if your eye is here over on the other side of this laser safety eyewear, your eye is going to be protected using these goggles from a specific laser source that's being used in the lab. So to further demonstrate this effect, we are going to dim the light in the room, and we are going to use our spray to actually see the laser beam light traveling through the air and then being blocked by the laser safety goggles. So as you can see, we have dimmed the light in the room. We can very clearly see our laser source right now, and a lot of laser light being produced and reflected off of the back screen. So I'm going to spray the area through which the laser beam propagates to clearly see it in the air. So here it is. So you can clearly see this laser beam coming out of the laser. Now if I put the safety goggles, you can see that over on the other side you can still see a little bit of a light hitting the back screen. It's kind of a little looks kind of like very strong because the light in the room is dimmed, but light is significantly blocked by the laser safety eyewear.